So let's tackle this problem, and we are supposed to find the minimum value of this whole function. And by now I know the moment I look at minimum or maximum, and even this heavy algebra looking expression, I know it will be reduced to something that will be more familiar to me. So even before using my AM GM or maxima minima concept, let me first simplify this expression and let me see what I get. And what do I mean by simplification? I'm going to separate out the terms. So I'm going to rewrite this as x square y divided by x dot y dot z. Similarly y square z divided by x dot y dot z, and I'll continue the story. I don't need to write down the whole thing. Zx square divided by x dot y dot z, because once you add them up together you will go back to your original expression. Why am I doing this? Because a lot of things will get cancelled and maybe I'll get a simplified expression. So the y and y will get cancelled. One of the x's will get cancelled because x square means there are two x's, one x in the denominator. Finally I'll be left with a x upon z. And now maybe if I can find a z upon x, I know the sum of x upon z plus z upon x. What is the idea I'm using? I'm using the idea that any real positive number plus its reciprocal, the minimum value is going to be 2. So we have some exposure to such an idea. So I think the story is heading that way, right? So x by z. Similarly, one of the y's will get cancelled, the z will get cancelled, and I'll be left with a y by x. So start doing it term by term. Z square x divided by x by z, one of the z's will get cancelled, the x will get cancelled, and I'll be left with a z by y, plus xy square divided by x by z, the x will get cancelled, there'll be a y left, and I'll get a y by z. So I see it already, a number and its reciprocal. So if I think of only these two terms, the sum is definitely going to be 2 or higher. Minimum is going to be 2. So I was lucky here. Otherwise the terms are spread out. That is the only challenge, right? Try this. Yz square divided by x by z. One of the z's will get cancelled, y will get cancelled, and I'll get a z by x. Did I have a x by z somewhere here? So maybe this is a pair of reciprocals, and once again the value of these two terms is going to be minimum of 2. So now I know the game. Nothing is new to me. Zx square by x by z. One of the x will get cancelled, the z will get cancelled, and I'll be left with a x by y. Do I have a y by x? So connect it to this. So now this pair will give you a minimum of 2. This pair will also give you a minimum of 2. And this pair will also give you a minimum of 2. So you are definitely getting a 6. Maybe higher, but you will definitely get a 6. So again, it looked bigger, but we have seen this kind of a story earlier. So not too much of a challenge, I would say. One more question, and I think this time from one of the major exams. So the product is given to me, x dot y dot z is equal to 216. And the question is just a layer of language, one extra challenge because it's a national level exam. You have xy plus yz plus zx cannot be one of these values. So which is that value that this expression cannot take? So I will ignore this part of the question. I see there is a product. Let me go for my maxima minima game and let's see what I can learn from there. So these are my terms. I'm thinking of xy, yz and zx. So if I think of the geometric mean, right, xy, this is one term, into y dot z into z dot x. Now if I simplify this, what I get is a x dot y dot z. By the way, these are three terms, so there will be a cube root. So xyz square and a cube root here. Why is this important? Because I know xyz is equal to 216. I'm not even working out the other side of the story right now. I know this is 216. So let me put 216 square here. Instead of a 216, can I write a 6 cube? And then can I further simplify it as 6 raised to 6? A cube root of that means basically the power is going to be 1 by 3. So you can also say instead of this symbol, can I write this symbol? So I have a 6 raised to 6 bracket raised to 1 by 3. So 6 into 1 by 3 greater than equal to sign and just carrying over is going to give you a 6 square. So this is my right hand of the story. On my left hand side, I will get what I wanted. I will get xy plus yz plus zx, and there are 3 terms, so I will divide it by 3. So I hope the journey till this point is clear. So let me just copy it here, xy plus yz plus zx, and there was a 3 in the bottom. That 3 will get multiplied to the other side. So 36 into 3, that means your overall product will be 108. That means this expression's minimum value, if xyz is 216 and xyz are positive numbers, the minimum value has to be 108. It can be greater than 108, but it has to be minimum of 108. Now, which one of them, that means essentially if you think of the number line, you're thinking anything on the right of 108 is okay. This 96 is on the left side of 108, which is not okay to me. I've just learned that anything beyond 108, anything is fine. So, can it be 326? Yes. Can it be 433? Yes. Can it be 291? Yes. Can it be 96? No, it cannot be 96. So, once again, the language layer, the top final challenges might vary, but notice the underlying logic or the game being played below the surface, and that is a game that you're familiar with. Use the AM is greater than equal to GM, or the variables are equal to each other's story, whenever whatever is more useful. And any such problem where you realize that okay, here there was no maxima minima mentioned, but there was a product given, which was again a clue. Okay, what games do you know around products? You definitely know this game, so try that. Another problem, same concept, x upon y plus z upon 12x plus 4y upon x plus x upon 3z. This is the expression given to me, and I'm thinking of the minimum value of this expression, but that is not the question. The question is one layer extra, that when this expression has a minimum value, what is the ratio of y upon z, or what is the ratio of z is to y, either is fine. So this minimum is once again a hint that maybe I have to use my AM GM concept, and again I have to reorganize this expression in such a way so that I can use the concepts that I have learned earlier, right? For example, let me rewrite this as x upon y and plus 4y upon x, right? This is one part of the story, and the other part of the story would be z upon 12x plus x upon 3z. Why am I doing so? Because then I can focus on each part of the story, that is like micro focus. And secondly, I notice that if I have a x by y and a y by x, I have seen such games earlier, and I know when I multiply them, I used to normally get a 1. There is an extra 4 here, but that should not be too much of a challenge. That means if I think of the product of these two terms, x into y into 4y upon x, the x will get cancelled, the y will get cancelled, and the product is equal to 4. So again, I am reaching that territory where I have the product and I am thinking of the sum. The product is given to me, that means I can start thinking of the AMGM concept. Or better still, that is why we spend that 10-15 minutes extra learning the variables are equal to each other. So if the product is given to me, remember the product is given to me, the product is a constant. In that case, if this is P and this is Q, P should be equal to Q. For what? For the P plus Q sum to be minimum, right? I hope you remember this from previous conversations. So x by y or 4 by yx, I want to make it equal to each other, and I'm thinking of p into q is equal to 4, I want to make it p equal to q. What I get is 2 into 2. So capture this value in the corner. Why? Because x by y, I have the value as 2, and if I can somehow find x by z or z by x, I will connect this to the value that I found, and I will have a ratio of y and z as such, right? So I hope you notice the very basic game here. I saw this expression, I rewrote it so that I can play this game, x by y into y by x, the product will be available to me. If I do x by y into a z by 12x, the product will not be a constant, I'll still get a variable in the product. So I don't want to do that. So I did that. So now the same game I will play here. Let me think of the product of z by 12x into x by 3z. The zz will get cancelled, the x will get cancelled, and I will get a 1 by 36 as the product. And once again, I have the product. I want the sum to be minimum, right? Because I'm thinking of the minimum. I want the sum to be minimum. That happens when the variables are equal to each other. That means again call them P and Q. They are equal to each other. So what will be the value? 1 by 6 and 1 by 6. So from this story, pick up any one. I get x by 3z is equal to 1 by 6. This 3 cancels a 6 and I get x by z is equal to 1 by 2. So I have a x by z into 1 by 2 and I have a x by y is equal to 2. And what I wanted in the beginning of the story is a, let's say, y by z or a z by y, either would be fine. So for that purpose, let me just divide this expression by this expression. So x by y divided by x by z. So what you will get further is, and this will work out to y into x in the denominator and x into z in the denominator, in the numerator, and the x will get cancelled. So I will get a z by y. I wanted a y by z, but that should not be too much of a challenge. So instead of a x by y, I will write a 2, and instead of a x by z, I will write a 1 by 2. So z by y will come out as 4 by 1. Y by z will come out as 1 by 4. So that's it, we are done with the game. The last bit was just basic ratio manipulation, but notice what is the essence of the problem and what is the clue. Once I have a clue, I can start reorganizing my equation. And again, familiarity with the game. We have seen x by y into y by x. So that was also another clue, that if I multiply these two, a lot of things will get cancelled and I will get a constant. If I multiply these two, a lot of things will get cancelled and I'll get a constant. That means I'll get a product. That means my AM GM story is going to work. So that is the essence of the game here.